There we go. And then now we're looking at a histogram. This is another vocabulary type of situation. Let me just go to, so it's got 50 students. And notice it says over there to don't do any calculations. I'm just going to grab this one to show, or do I have a red? I don't think I have a green. But like, notice the let's draw the skew here. As you can see, there's the skew. Skewed. Right. Getting a little shaky. The mouse is not working with me, but anyway, it's skewed to the right, right? Because it's the direction of the skew. That means our mean is going to be, so that means I'm going to guess that the median is somewhere around here. But before I guess, let's look at the choices. It's asking for the so the mean is between 4, it is to the right. It's got to be to the right, right? That mean has got to be over here because it's being skewed, right? Remember, the mean goes in the direction of the skew. So, in 1, it says it's symmetric. It's not symmetric. A is out. The mean, I would say that's the median between 2 and 4 when it's describing that right there. The mean, I'm thinking, yeah, 4 to 6 would be about right. I would almost think it would be over here. But 4 to 6 is the best estimate we can go with based upon this. It's skewed right. See what's wrong with D. It says it's roughly symmetric. So our answer has to be Charlie. Okay, so this one is going to take a little bit more time, but we should be able to do this in the Desmos. And we'll see how well the brain is working here. So it gives us the mean is 53.1. So we'll go ahead and say mean, well, let's just put that in. That's what it is. I'm not sure I can identify any variables the way I know I can do an S here. The standard deviation is 2.2. So I guess we can let this be an M. And so suppose the standard deviation is 2.2 centimeters and the shape, okay, here we go, it's symmetric and unimodal. So that means we can apply the empirical rule. But again, this is that fantasy land of the normal curve. So say, what is the range of the birth links? 1 standard deviation below the mean to 1 above the mean. Okay, so we're going to use this idea. So below would be 50. Well, let's just do it this way: mean plus 1 standard deviation would be 55. The mean minus 1 standard deviation would be 50.9. So those numbers should sync. The upper 55.3, and the other should be 50.9. Notice it says integers or decimals do not round. So do not round. Let's check our answer. There we go. We're rolling. Is the birth length of 55 centimeters about 20, and here it gives us the value, 21.9 more than 1 standard deviation? The answer is no, right? Because that's within one standard wait. The answer is yes, sorry. Because, see, that would be less than this one standard deviation, right? Sorry, misinterpretation. Let's check it. There we go. One more question, and I need to pause this. Let me go ahead and pause now so I save some space. I'm going to try to do two more until my computer crashes. I have a very old computer with a old Windows 7 partitioning, so I got to be careful about my hard drive when I'm doing these things in PowerPoint. But anyway, this should be similar. Data on residential energy consumption per capita measured in British thermal units has a mean of 67.7 and a standard deviation of 5.1. So now we're gonna do, so this one's gonna have a mass, it's gonna have A through D. So between which two values would you expect the middle 68%? Right, remember that is the one standard deviation. So notice how I already had the variables assigned, and StatCrunch gave me a really quick answer. Remember, timing is key on these things because you've only got 3 hours to do it. So the upper is going to be between, I'm assuming it wants us to write this in respective. So let's put the 62.6 as the lower, and we'll see if that's a misinterpretation, and if 72.8 is the upper. Let's check to make sure we have it all rounded to one decimal place, and it appears to be correct. Let's check it. Nice job. Now, between which two values would you expect to find the middle 95%? So the only difference there, remember, the middle 95% is 2 standard deviations away from the mean. So there's our new values. So we should have 57.5 there and 77.9er over here. Let's see if that's correct. We're rocking and rolling. And then now it says state, if a state on the East Coast. So I suppose this must be per capita. Oh, bordering. Oh, here's a confusing part. It says bordering on the Atlantic Ocean, so that's got to be East Coast stuff, right? So this is the entire sample. So remember, unusual is going to be greater than 2 standard deviations away. So either greater than 77.9 or less than 57.5 would be in those two tails of the 5%, which would be about 2.5% on the tails of a normal curve. So 56. Notice it's one less, so it would be unusual. Yes, so it's not the nose. Notice this says not more than 2. It is more, right? It is more than 2 standard deviations. There we go. We're rocking and rolling. Okay. So I'm going to go ahead and try to do this one, and hopefully it doesn't crash my hard drive. Going on to, oh, I haven't completed it yet. Be careful on that one. Remember, it was part A through D. Let me find the Desmos. Maryland, and Maryland is bordering on the Atlantic Ocean at some point, I think. It's a little bit, yeah, it does, right? So per capita, residential energy was 71.3 BTUs. Is that unusually high? No, 71.3 is within the 2 standard deviations. So this one is a no. We just eliminate the 2 yeses, but we got to read them carefully. Like, let me see. It is not more. It is not more than 2 standard deviations. So there we go. Alright, now looking forward to the next one here. I just want to save my space on the hard drive, so bear with me.